Hi everyone, welcome back. In this video, we are going to discuss the top Spring Security interview questions. Let's begin. The first question is, what is Spring Security? Spring Security is a framework that protects Spring applications. It provides authentication, authorization, and many security features out of the box. Without Spring Security, you would have to manually write filters, sessions, password checks, access rules, and protection against attacks. With Spring Security, all these tasks are already implemented using a well-tested and stable architecture. The reason companies prefer Spring Security is because it integrates perfectly with Spring Boot and supports modern security needs such as JWT, OAuth 2, SSO, CSRF protection, CORS rules, password hashing, and role-based access. The second question is, how does authentication work in Spring Security? Authentication is the process of verifying who the user is. When a request comes in, Spring Security intercepts the request using a filter chain. Inside this chain, the framework checks if the user has provided valid credentials. For example, username and password or a JWT token. If the credentials are valid, Spring Security creates an authentication object and stores it inside a security context. This security context travels with the request, so any controller or service can check who the current user is. If the credentials are invalid, the framework blocks the request automatically. Authentication is always the first step in the security process. The third question is, what is authorization in Spring Security? Authorization checks what the user is allowed to do after authentication. For example, a manager should be able to access admin APIs, but a normal user should not. Spring Security allows you to apply authorization at URL level, method level, or service layer. After authentication, Spring Security stores roles, permissions, or authorities for the user. When the user tries to access a protected API, Spring Security simply checks if the user has the required role. If yes, the request continues. If not, the request is blocked with a first forbidden error. This ensures that even authenticated users cannot access things they are not allowed to use. The next question is, what is the security filter chain? Spring Security works completely through a filter chain. Each filter has a small task, and all filters together build the full security system. For example, one filter checks login credentials, another filter checks JWT tokens, another filter handles CORS or CSRF, another filter decides if the user is authenticated. When a request enters the system, it first passes through the security filter chain. If everything is valid, the request finally reaches your controller. In latest Spring Boot, you configure this chain using a security filter, chain bin, and the HTTP security object. This approach gives full control over authentication and authorization logic. The next question is, what is the difference between user details and user details service? User details is an interface that represents a single user. It contains the username, password, roles, and status flags such as account locked, account expired, or enabled. Spring Security uses this object internally to understand who the user is. User Details Service is an interface used to load the user from a database. It has one method called loadUser by username. Inside this method, you fetch the user from the database and convert it into a user details object. Spring Security calls this method automatically during login. This separation allows you to use any database such as MySQL, PostgreSQL, MongoDB, or even an in-memory list. The sixth question is, what is password encoding in Spring Security? Spring Security never stores plain text passwords. It always uses encoded passwords. Password encoders convert plain text into a one-way hashed value. Even the developer can't reverse it to find out the original password. The bcrypt password encoder is the most commonly used encoder. It is strong, uses salting, and protects against brute force attacks. During registration, you encode the password. During login, Spring Security takes the incoming password, encodes it again, and compares the hash with the stored hash. If the values match, the authentication is successful. The seventh question is, what is CSRF and why is it important? CSRF stands for Cross-Site Request Forgery. It is an attack where an attacker tricks a user into performing actions on a website without their consent. For example, submitting a form or transferring money. Spring Security enables CSRF protection by default for web applications that use session-based login. It creates a unique token for each session and requires this token for sensitive operations such as post or delete requests. If the token is missing or incorrect, the request is blocked. For APIs that use JWT tokens, CSRF protection is usually disabled because JWT is already stateless and does not use cookies or sessions. The eighth question is, what is JWT authentication in Spring Security? JWT stands for JSON Web Token. It is a stateless authentication mechanism. Instead of storing user session data on the server, the information is encoded inside a token and sent to the client. The client sends this token with every request in the authorization header. Spring Security validates the token using a custom filter. If the token is valid, the user is considered authenticated. JWT is very popular in microservices and modern API development because it does not require server sessions, works well with load balancers, and is easy to use in mobile and front-end applications. The next question is, what is method-level security? Spring Security allows you to protect individual methods using annotations such as pre-authorize and post-authorize. For example, you can restrict a service method by checking the user role before execution. A pre-authorize annotation checks access before method execution. A post-authorize annotation checks after execution, usually for returning filtered data. Method-level security is useful when your business logic requires deeper validation beyond URL access. The 10th question is, what is the Authentication Manager? Authentication Manager is a central interface that performs authentication. When a user logs in, Spring Security passes the authentication request to the Authentication Manager. It then delegates to the correct provider, such as DAO Authentication Provider for username and password, or JWT Provider for token validation. If authentication is successful, it returns a fully authenticated authentication object. If authentication fails, it throws an exception. In modern Spring Security, you create an authentication manager bean manually using the authentication configuration. This design gives full control over custom login logic. The 11th question is, what is a security context and how does it work internally? The security context stores the authentication information for the current user. When a user logs in successfully, Spring Security creates an authentication object and places it inside the security context. This security context is then stored inside a security context holder, which is a wrapper around thread locale. Thread local means the data stays attached to the current thread, so controllers and services can access the user information at any time during the request. In asynchronous or reactive applications, thread local does not work reliably, so security context handling must be customized or delegated using special context holders. When the request completes, the security context is cleared to avoid leaking user data. This entire flow is important for understanding how Spring Security maintains user identity across the request lifecycle. The 12th question is, what is a custom authentication provider and when should you create one? Spring Security includes default providers like DAO Authentication Provider for username and password. But sometimes your application requires custom authentication logic. For example, validating credentials against an external API, checking OTP-based login, verifying a hardware security token, or performing database lookups that do not follow the default schema. In those cases, you create your own authentication provider, you override the authenticate method, perform your business logic, and then return a fully authenticated authentication object if the credentials are valid. If the credentials are incorrect, you throw an authentication exception. You also implement supports to identify which authentication type your provider works with. By registering this provider in the Authentication Manager, Spring Security becomes fully customizable for enterprise login flows. The 13th question is, how do you secure microservices using Spring Security and JWT? In microservices, session-based security does not scale well because every request may hit a different server. JWT solves this by storing user details inside a signed token on the client side. When a user logs in, the authentication service issues a JWT. The client attaches this token to every request sent to other microservices. Each microservice validates the token using a shared secret or public key and rebuilds the user details from the token. No database lookup is required for each request and no session is stored on the server. Role-based or permission-based rules can be applied inside each microservice independently. In large systems, JWT validation is handled by API gateways or service meshes, which reduces load on individual services. This architecture is extremely common in real enterprise systems today, especially with Spring Boot microservices. The 14th question is, how do you implement role-based access control and permission-based access control in Spring Security? Role-based access control uses simple roles like user, admin, or manager. You secure endpoints using role checks, but enterprise applications often require much finer control. For example, a user may have permission to read orders but not update them. Permission-based access control gives this level of control. You assign authorities such as read order, update order, or delete order. In Spring Security, authorities are checked using has authority or has any authority. Roles are just authorities with a prefix, but permissions represent granular operations. In large applications, permissions are loaded dynamically from a database and attached to the user during authentication. This allows complete flexibility in controlling access without changing code. The 15th question is, how do you handle CORS and CSRF in a modern Spring Boot application? CORS and CSRF are two separate concepts, but developers often confuse them. CORS protects your application from unauthorized cross-origin requests. For example, preventing another website from calling your APIs without permission. You configure CORS rules using allowed origins, allowed methods, and allowed headers. If the front end and back end are on different domains, CORS must be configured properly, or the browser will block the request. CSRF protects authenticated users from unwanted actions triggered by malicious websites. In session-based logins, CSRF protection should stay enabled. But for stateless APIs using JWT, CSRF protection is usually disabled because there are no sessions or cookies. A senior engineer must understand when to enable or disable these protections because incorrect configuration can break the application or expose it to attacks.